In this tutorial, we will study how to manage state using BLoC. Flutter BLoC is a state management library for Flutter applications that follows the BLoC, business logic component, design pattern. It helps manage the state of your application by separating the business logic from the UI layer. With Flutter BLoC, you can handle complex state changes, update UI components, and manage asynchronous operations efficiently. It provides a clear separation of concerns, making your codebase more maintainable and testable. In this tutorial, we will explore two types of examples. First, we'll delve into the BLoC design pattern method. Then, we'll examine how to use the Flutter BLoC dependency. While BLoC and Flutter BLoC are related concepts, they refer to different things. BLoC is a design pattern for managing state and handling business logic in Flutter applications. It separates the presentation layer, UI, from the business logic and state management, making the code more modular and easier to maintain. BLoC can be implemented using various libraries or even plain Dart, without relying on any specific package. Flutter BLoC is a popular state management library for Flutter that implements the BLoC pattern. It provides utilities and classes to simplify the implementation of BLoC architecture in Flutter applications. Flutter BLoC provides tools like BLoC, BLoC Provider, BLoC Builder, BLoC Listener, etc., to create and manage blocks effectively. It offers features such as state management, event handling, and stream-based communication between components. In summary, BLoC is a design pattern, while Flutter BLoC is a library that helps developers implement the BLoC pattern in Flutter applications more easily. First, we'll explore how to implement a simple example using the BLoC method. Then, we'll proceed to utilize the Flutter_BLoC dependency. Create a blank Flutter project. Create a new Dart file. Then add a class inside it, with the class name CounterBLoC. We are developing a simple project to increment and decrement values using this block. Declare a local variable named counter. Declare another stream controller variable named counterStreamController. Dart async is imported. The data type is integer. StreamController is a fundamental class used for working with asynchronous data streams. It serves as a source of data that can be listened to and consumed by various parts of your application. Then create a stream sync getter. Stream sync is an interface provided by the Dart async library that represents the input side of a stream controller. It allows you to add data, errors, or close the associated stream. Then create a stream getter named counterStream. In Flutter, a stream is a sequence of asynchronous events or data. It represents a source of asynchronous data that can be listened to and processed by various parts of your application. Then create three functions for incrementing and decrementing the counter variable and disposing the controller. Then the variable is added to the sync. Open the main.dart file. Import the created counterblock.dart file. Then create an instance of the counterBLoC class. Create a dispose function and call the dispose function from the counterBLoC class. Then add a stream builder widget inside the body. The type is integer. Include the required parameter stream, and call our counter BLoC stream. Set the initial data to 0. Add another required parameter, builder, which includes the user interface designs in here that interact with our business logic using BLoC. Return a column. Include a text widget for displaying the current counter value. Display the value using snapshot.data. Then create a row to include buttons for incrementing and decrementing. Add an elevated button. Text should be increment. Call the increment counter function in the onPressed event. Then copy and paste for another decrement button. Change the text and function accordingly. Then run the app. It's working very well. Now we are moving to another method for using the Flutter_BLoC dependency. For that, we remove all the current code and start with a fresh project. We need the Flutter_BLoC package, so search for it and find it. To install it, copy the dependency and paste it into the pubspec.yaml file. Then press the pub get button. Next, create a Dart file and import the dependency. Create an abstract class, counter event. Then create 3 more classes for increment, decrement, and reset. These classes should extend from the counter event class. Create a class that extends from BLoC. Set up a constructor to create an instance of the counterBlock class. Call the constructor of the superclass of counterBlock, passing 0 as the initial state value. Register the handlers for our events. These handlers will handle incrementing, decrementing, and resetting events by updating the state accordingly. Next, open the main.dart file. Import the flutter_block package and the counter_block.dart file. Wrap the homepage widget with the block provider, passing the counterBlock as a parameter. Move to the build method and create a block provider. Inside the body widget, create a column. Add a block builder widget inside the column. The builder should return a text widget that displays the counter value. Next, add a row and include 3 buttons inside it for incrementing, decrementing, and resetting the value. Call all our events on the onPress event. Finally, run the app. Everything is working perfectly. These are the methods of state management using BLoC. Thank you for watching.